All right, so now we should be good. So if we have the x, y axis, and I draw that, probably x to the third degree polynomial, that's the zero, where y equals 0, right? Pretty simple stuff, right? And I will be completely honest, I don't even get all of this. Like, this is some tough stuff. Like this stuff, when I was reading through it, I'm like, I don't get that. I don't understand that. I mean, I do and I don't. Like, I can tell you what it's saying, but I don't understand how you can call it a zero and have this happen. So, does that have zeros? We have an x squared term. It does.
Yeah, the y.
No, because we said a zero is where y equals 0. Does y equals 0 anywhere? Because this goes forever that way, right? So is y ever 0 on that line? It's not, right? But they're basically, these theorem things are basically telling us we do have zeros for every pretty much type of polynomial. So this is why we have complex. Because the complex numbers allow us to create a zero, even when technically on a graph, there's not a zero. So let's think about what is, you guys did some transformation stuff, so it's still a good review for that stuff. What's happened? Let's just say it's just x squared, which I think you know parabola is x squared, so not multiplying times anything. But what are we definitely doing? Actually, let's make it even better. Let's say that it's also right on the vertex. Pretty good right there. It is right on the y-axis, and that value is 1 on the y-axis. So what's the equation that this would be? Again, I'm just telling you we didn't multiply the x squared by anything. So what's the only thing we did to transform it? If you remember their transformations. Which way to go? Where, if let's say it wasn't transformed, where should that vertex be? Okay. So it has been transformed. So what did we do? Not -1. That's when that's the left or right, where it's the opposite. If it's the y value, it's just exactly what you would think. We just shifted it up, which means we just added 1. Yeah, when it's up and down, it's exactly what you'd think as far as adding or subtracting. When it's left and right, it's the opposite. So that's just y equals x squared plus. Or f of x equals x squared plus. Now, let's say we wanted to solve for zeros. What would our first step be if we want to solve for x? Solve for when would x be 0? Try 1, right? Next step. Anybody remember anything about that?
That would be an I.
Ta-da! That's why we have I. Because even though
that unit too.
Visually it doesn't have zeros, there are times in math, mainly probably science, I'm sure, when you need to take the square root of something to come up with another value in the process, and you got to be able to keep moving through it. So that's where complex numbers, I think, is the fact that, okay, now we can at least keep moving through, and we'll wind up having an I in it down the road, but at least we can keep moving through with equations and with calculations. So that's my shortened version of all this first thing.
But this one is like weird. So it's saying every nth degree. So would that be like any degree ending in th? Or is that just any?
Which are you talking about? The fundamental theorem of algebra? Or
yeah, like not the purple boxes, but the little paragraph above it. Or it says the fundamental.
We'll just read it. We'll go on.
It says in the complex number system, every nth degree polynomial.
Oh, wait a minute.
Yeah. So is that talking about?
Yeah, that's
the n
so.
pH?
That's what I'm saying. So it's telling you if you have x squared, there are two
Okay, so it doesn't matter.
solutions, two zeros. Even though we don't see any zeros on the graph, there are two zeros. What are my two zeros? So I got down to it. What would we say that is? That's I, right? So what are my two zeros? So my two zeros, plus or minus.
I would just the number. Would you say like plural? Like would you say like fourth, fifth? Like what's the n and th?
No, it's the same. Yeah, the highest degree, highest exponent is the nth degree. So if it's highest exponent is 5, it's a fifth degree polynomial. So that means there are 5 solutions. Some of them may be involving I, but technically we could come up with 5. So if you look at example 1, I'm going to skip it because it's kind of what we just did. It's just more complex. They solve that thing out, and they come up with zeros that involve I. Negative 2i, positive 2i, but then also 0 itself.
I don't like this class anymore.
We'll get to some other stuff that makes a little more sense, but yeah, this stuff is tricky. So here's what you need to know. The next one. Oh wait, that wasn't what I thought. All right. So look at, so not where it says in the box the rational zero test. Below that, it says the possible rational zeros. That's what we're going to focus on for this one. So it tells you that it's the factors of the constant term. So what's constant term mean? Yeah, it's the end. Whatever's at the end. It's just a number. No variable with it. So that's the part that's going to be on top. And then the factors of the leading coefficient. So what is that going to be? Yeah. And make sure it's in order. So you need to make sure the highest degree exponent, or basically the biggest exponent, is the first term. And then that's the leading coefficient. So in this case, we have a 1 and a 1. So what would I get for my possible rational zeros? What's my leading? So what's the top and the bottom of that? That's what you would think. It's close. Again, you have to take into account positive. That's the only thing you got to remember really on this. So it winds up that there are two possible rational zeros, -1. Because here's how you figure this out. You have to take all versions of these two, like all combinations. So I could have +1 over +1, +1 over -1, -1 over +1. And then, yeah, you get the point. And again, when they're both 1, it doesn't really change a whole lot. But sometimes when they're not both 1, it'll, what about, oh, negative over negative. And then that reduces down to the fact that you really just have -1 and positive. So that's the process, really, no matter how complex they get. So I'll let you try to do the checkpoint at the bottom of 274. Here, let me do one for you.
Yeah, because it says if possible, and that scares me. And I don't like that.
All right, what are my factors of 2? That's a 2 at the end. Factors of 2. Well, what do we have to do? There you go. We put that on top. Now, what are my factors of the leading coefficient, which would be that? Now make all the combinations you can and figure out what the possible rational zeros are. So we'll try it on your own, then I'll show you, and then you can try to do it. Okay. Well, that's out. Lose your yeah. Oh, yes. All right, thank you. Did I do those? The work thing, like where you get to go work or something. Oh no. I gave a bunch of that. Yeah, whatever's on top has to be on top. Whatever's on bottom has to stay on bottom. And then you got to try all different combinations of it. No, you're using number. You're using the coefficients. Coefficients are always numbers. Well, actually, technically, not all. But for these problems, we're only going to do it. Probably not. I mean, if I did, it would take me forever to find it. What will not take me forever to find
Is it mechanical pencil?
is a mechanical pencil. Well, I'm out of luck.
I don't break the print.
Too good for that. Huh?
Yeah. I get the urge to break them.
What's that?
I get like the urge to break them. I can't.
Huh. A ton of other decorative pencils. What if it was a really pretty pencil that you still like?
That depends. Does it have a really nice point?
Sharp.
How pretty is the pencil?
Oh man, that's so pretty. I have a box. I'm like, I'll keep looking for now. This will, maybe you can resist for long enough to get something done. It's hard to find it.
I get so much done. Oh, these are pretty. I like
Yeah, I told you. So you want me to sharpen it, or you want to sharpen it to your specifications?
I'll sharpen it to the best.
So there's one up here on my desk, right there.
This thing. I swear to God.
I can put that in the raft. There's no word. There's five things. Oh, beans.
Did you guys figure it out? The answer to the problem?
Yeah, I'll be honest. I don't know the answer. We're gonna figure it out together in a minute.
Emmanuel, did you get it?
Oh. Would anybody else like a pretty pencil?
They're very pretty. They're shiny. They're pretty.
Told you. I know.
You go. You go wake up and tell them if you go.
I know, right?
Get pretty pencils.
I all had a pretty pencil. I used to have some sort of pretty mechanical pencils. Right?
I have pencils just like this one.
Yeah, they came from the school. Oh, I'm missing like one box of pencils, and it's that one box that has the mechanic. Oh, you know what I'm freaking again? This is not the whole box. Huh. That was crazy. I didn't get them all. I went too away. Thank you.
Neck.
Look at the two.
Ain't no way.
Did you get one? Got that one? All right.
The grip on that one feels weird on me.
I might have another one there. The grip issue on it.
Oh, can I just take the lead out of it?
Yeah.
That's all I need. I can just use this.
Actually, I think it's bigger lead. Anyway, I look really thick lead on that.
This is 0.5.
I look it's out. I like wearing that. Yeah. Yeah, that one seemed like it was the bigger.
Stick with this one.
Oh, look at that.
0.5 lead?
Oh. 0.7.
Oh my god, I love you.
Oh, look at that. Wait, is that what you need, 0.5, or you need 0.7?
0.5.
All right. Well, if you're that 0.5,
Man, you
I think
sticky
most of that is 0.7. Are you asking about this?
Yeah.
All right, we're gonna do it right now. All right, so here's how you do it. Now that we've taken care of Rachel and her pencil needs. So we have 3 different numbers, and then each of them has a positive and negative version. So we just create as many. Here, let's do this. Just create as many combinations as you can create. Some of them will be duplicates, like we're gonna get 1/1 a few different ways. So I just start with +1, and then I pick all 4 different variety or variations of the other one. So I just pick this one in the positive version. I can take +1 and put it over +1, and then +1 again over -1. So I've taken care of +1 in both of these. Now I do the -1. So I'm taking -1, and I'm going to do the same exact thing. Could be over +1, or it could be over -1. That really only creates 2 possible rations, -1. So now I'm going to move on to +2. Oh, so my rational zeros, possible rational, -1 and 1. So now same thing, +1, +2, -1. -2, +1, -2, -1. Again, that only creates 2 different numbers. +2, +2, -2, -2. I don't know why we would positive from that. So 4 rations. 4 possible. Oh, I do actually.
Did you need to write?
Wait, what kind of red pen? Just like a normal ballpoint pen? Why does it need to be red? I'm curious. Oh. I was gonna say, what about highlighters or that kind of stuff? Working.
I use both.
All right, so now I want
You
you
guys like to practice
to.
with?
Well, I want you to do
I'm just gonna show you. Because these two don't know how fractions work. 2/1. You have 2 groups. And they each have 1 in them. You have 2 things. So this gives you +2.
all. And then some of them will be like, this is +1, but so it is.
I don't know how he got -1. I don't think he
However
meant
many
to write
different
-1.
numbers you can make out of that.
Because this
Which again,
is the same thing, but
trying to make sure I'm doing this right, because that doesn't seem right. But I didn't create I didn't have an original polynomial from that.
you get it now, man?
What
Or
if
you
you had
just
x
think
squared
if you feel dumb.
and then x squared plus 2? That shouldn't have 4 possible zeros.
No, Emmanuel didn't
Oh, wait.
understand. They didn't understand
sorry.
fractions.
Why? This was the Aiden.
Oh.
So again, I see now what I was doing, but again, I don't understand. So this -1, we already, oh, I got rid of that. Well, actually, that worked out. That -1 we don't need because we already had -1 up top. So again, we eliminate that one. There's how many different rational. Yeah, how many possible different rational zeros can you have? But here's what I don't understand. They don't give us an example of this. What if we had, I'll have to find, and if this, here's my question to you. You can see if you can answer it for me. What if we have this equation? I'd still come out with the same numbers. But I shouldn't have three possible rational zeros. Because I only have a square in terms. And if I would have put if I had a coefficient here, I'd have even more. If I put a coefficient with more factor there. I don't understand how the coefficients. Can't how the coefficients determine
So you don't get out.
Oh, we'll just follow what the book says. I'll have to get somebody to give me the why behind it.
Do you get it now?
Yeah, I get it.
All right, so let's go ahead, look at example 3. Let's try to work through example 3 on our own, according to that. Oh, I know what it is. Yeah. We then have to test them. That's what it is. So that's what we're missing. Okay, so these are, so here, make this note. I read through it last night just now. So make this note. These are the possible rational zeros. Doesn't mean they are. Make that note. We can just come up with what's possibly a rational zero. Does not mean it is a rational zero. We have to test it out to see if it's a rational zero. How do we do that? So if it's a rational zero, that means when we use it, we'll get y equals 0, right? That's the definition. We said that at the beginning. A rational zero is where y equals 0. So take these values, and I don't have an equation, so we can't really, well, yeah, we can solve it here. Take those 3 values, plug them into that equation. So +1, -1, +2. And if you get 0, then it is a rational zero. If you don't, then it's not a rational zero.
-2.
No, it was negative. Oh, there is negative. I didn't write that. Oh, maybe that's what I meant to write instead of the -1. Yeah. So yeah, so take those 4 possible rationals and plug them in. Again, if you plug one in for x and it comes out to be 0, then it is a rational zero. So the possible rational zeros are these 4. The actual rational zeros you have to figure out from those possible by plugging them in, setting them equal to 0. Or no, I'm sorry. Plug them in, and if they equal 0, then it is a rational zero. Yeah, I haven't been writing a pass. I've just been handing a piece of paper. Yeah. Oh. X, because again, if it's a rational zero, then that means y, like the y value will be 0 when we plug it in. Right? That's where it hits the x axis. So on the x axis, y is 0. So we would plug it in and see if we get 0. So it makes it the answer for the y. Oh, because we're doing rational. So what are the zeros? What are the zeros? We graphed this in the beginning. What were the zeros in this? Well, they were, but what, like, how would we solve and get, like, we set this equal to 0, what would we get? We get imaginary numbers, right? So there are no, you're right, there are no rational here. They're only imaginary. So we wouldn't get it for that equivalent. So go ahead now, we'll go through this one again. Go ahead and try to do 2 without looking at like what they did. Just look at the equation. Go through this process here. So go through this process. What are the factors of the leading coefficient and the factors of the constant? The example 2. So I can't remember that. X cubed plus x plus 1. I think that. So that's a pretty simple one. There's only one number in it. So, and then try to do the check. The check problem a little better. So try to do the check problem. So the example 2 and then the checkpoint at the bottom of page 272. And then we'll see how we do. They don't give us the answer to the checkpoint, but I'm sure we can all figure it out. And remember, the key is first you're finding the possible rational zeros. Then you have to plug each one of those in to see if you have any rational zeros. Oh, I'm so tired. Man. We'll start working on it in a minute. Oh, I gotta do attendance. Oh, no, no. Yeah. I'll start putting it in focus now. As soon as I finish attendance, we'll start working through both of those. Let's see. Not here. Here. Not here. Whoa. I was here today. Four. Whoa. Here, that's all that hashtag. Here. And who do we have? Harvard, Peter. So, all right. So the first one's pretty easy. So I'm yeah, there were none, right? So we got -1 and +1 were the possible natural. When we plug those in, what's the equation? If we plug in +1, it definitely doesn't equal 0 because we just keep adding stuff. If we plug in -1, we get 2 plus -1, so we get +1. So no rational 0. Um, let's take a look at the graph. Oh, by the way, did you guys do that exercise this morning with you guys definitely do. Like, a lot of you talk about, as soon as I graduate, I'm moving out, I live on my own, blah, 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 blah. Well, it's expensive to live on your own. So that exercise this morning, which a lot of you probably weren't even in your first period class or your second period class, technically. That's the kind of stuff you need to start doing right now, especially if you plan on immediately moving out, whether you're going to college, just want to be on your own, working, paying your own bills. You should have received. That is cheaper, but still, you got bills. May not have rent, but you got bills. You still got bills. You gonna eat? You gonna eat? You're good. Where is that stuff? I don't know what I did with all my extras, but yeah, it gave you like this. It was just one page, front and back. One side was like all the different things that are important to you and your like quote unquote the lifestyle you want to live. So, one of them was, are you gonna live at home or are you gonna live on your own? One of them was about the kind of food you like to eat, like you always make your own food or do you like to eat out? Like just gave you a whole bunch of different options. Oh, here it is right here. So yeah, it was this thing. So it gave you a whole bunch of different options to fill out. And I would encourage you to do this. Like I'll give you one if you didn't get one, even if it's not through the exercise today. Sometimes you don't think about some of the expenses you might have.
Yeah, I want to see how expensive my
Yeah, again, if you guys are juniors and seniors, it's literally called reality check. So you need to start thinking about these things as you get, especially if you're one of those people that can't wait to move out, because these are your potential expenses. Some of them you won't have, most of them you will have. And so, like again, maybe lower than some people, but you're all gonna have a phone bill that you're gonna be paying. You may only have one phone bill, but you're gonna have a bill. So those kind of things are what you need to understand. And again, I've done this many, many times on my own, setting up a budget, basically is all it's called. And I forget expenses every once in a while, like, oh crap, I didn't think about that. So again, normally I don't forget the big ones because you know the big ones. But again, little ones add up too. And then on the back, it has a chart of like salaries. I'll just tell you right now, these are not accurate. Like, don't think this is what you're going to be making. I'll just tell you that. Yeah, that kind of stuff. Like, well, some things just go up based on market conditions. Like I was in insurance, I sold insurance. Different kind. It wasn't for individuals, it's for larger corporations. Sometimes the market just dictates that insurance goes up. It has nothing to do with you at all. You have a great driving record, but your insurance just goes up because the market winds up having some kind of bad experience, a large scale bad experience, and the whole market just goes up. There's nothing you can do about it. Yeah, those salaries, though, just to give you an idea, and especially since we're a firefighter school, that's more around what you'd be making as a firefighter. You're not going to probably come in making the numbers they say on the back of this sheet. So, and that's the way it is for a lot of you. Like, I was in human resources, or I worked with human resources people. They don't make the money that you see on that sheet. There may be one person in a whole department that makes that, but 90% of the people in a human resources department aren't making anywhere near that $80,000. I knew a woman that had been working in human resources for 30 years. Oh, granted, this is a lot back. 30 years. She was a manager in charge of recruiting for Wachovia Bank, which is a big bank. They merged, so they're not Wachovia anymore. She made like $50,000. Now, granted, that was a while ago, but she also had a very high position within human resources. I don't know where they got those numbers from, but every job has ranges depending on experience and college degree or no college degree, just all kinds. So just know those are inflated.
I got 59 points.
Yeah.
I feel like that's.
I got 42. You only got 42. That's pretty low. I figured you'd be higher. Although that's not even that bad. I think the sheet goes up. Yeah, I was gonna say the sheet goes all the way up to 90 or more. So yeah, that's not bad. So again, just know that's the kind of stuff that you're gonna need to do on a pretty regular basis because things change over time. So they have stuff like even just internet, like all that stuff.
Yeah.
Is that all they're saying?
It's all utilities.
Yeah, I would encourage you to do something. I have a whole spreadsheet in Excel that I created. I'll go back and look at it every, year or two just to make sure things haven't gone up significantly. Obviously, the more money you make, the less you have to worry about it. Let's see. So let's go back to our checkpoint. Any questions on that then? Didn't even do the checkpoint. So let's do I'm sorry, I didn't even do the example up here. We'll just go straight to the checkpoint. You guys tell me what the factors are. What are the factors of the constant? That goes on top. So plus or minus 1. So we only need to write 1, 2. We don't need to write that one twice. All right. So what about on the bottom? I don't even know what the leading coefficient was. No, there's 1, then it's 1, right? So there we go. So let's just go through every possible combination. Plus 4, plus 1, plus 4, minus 1. I mean, we don't really need to do minus 4 because that's just going to create those same things. So if you start taking some shortcuts, I'm fine with that. But minus 4 over positive 1 is just going to be negative 4, which we already have. Minus 4 over minus 1, or negative 1, I should say, is just going to be positive 4. So we really already have everything we need. So I'm not going to keep writing all of them up as we get into more of them. So now we can move on to the positive 1 over positive 1, negative 1. They're the only two for that. Again, I don't need to do negative 1 on the top. It's just going to lead me right back to positive 1 and negative. So now we're on to 2. Kind of the same thing. That's all I really need because if I put the negative 2 on top, I'm still just going to get negative 2 and positive 2. this thing over here. So it's the factors of the constant. So that was the one on page, look at page 274. Like it says possible rational zeros, there's a little fraction in the middle of that page, 274. See it? Yeah. Oh yeah, why did, well no, we use 4, the constant. And then we just something. Yeah, right? Minus 3.
What'd you get?
Wait, I'm not. You see where it is? You see it? That's just the definition.
Okay.
This is how we find the possible rational theory. We just do this and we do this. So that's not the constant. Constant is just. Yes. Well, that's a possible factor.
Way over 60.
1 and 4.
Like
2 and 2.
7.
All right, so the only possible rational zeros for this, positive 4, negative 4, positive 1, negative 1, positive 2, negative 2, 6. So now to find out if we have any actual rational zeros, you just plug it back into the equation. If you haven't done that, actually, if you haven't done that, I'll let you do that for a minute. You should, but that should have been your first piece. So this, I mean, I see this being a 2-part question. Come up with the possible rational zeros, and then tell me actual, like, what are the rational zeros? And it might be 0, you might not have any, or you might have, and, oh, I don't understand why we did not have rational zeros. X plus X plus 1. So you guys finished that. I want to graph this because I don't understand. I would have thought that would have had rational zeros. Today's tryout still, right? Maybe you should be. That kind of attitude that gets people cut. I hate it when, oh, I'm going to make it. I'm not worried about it. I'm going to make it.
Like, I'm still.
I'll cut you just because of your attitude. All right. All right. You better try out like you think you.
The only thing I could think
Like you
of-
mean it. You better try out like you mean it. I don't get that. There is a rational zero. Possible rational zero. I don't. I'm going to tell you right now, we're going to just follow what the book says, but I don't understand it. Because if I grab, I mean, I'll show you what I'm talking about. So we just said for the, I mean, it even says in the book that there are no rational zeros. Oh, okay, so it explains it. All right, so I'll just show you really quickly. So here's what I did. I don't understand. Oh, I get it. I get it. All right, so one more thing I forgot to mention. I didn't even think about that. I was thinking about real zeros, not rational zeros. So what does rational mean? Let's go back. I need to, oh, this is a big part of this. Go back. What does rational mean?
that it's a whole number.
Not a whole number. Well, it's actually the opposite. Rational means what? So what's the opposite of what you just said? It either repeats or it terminates. That's what rational means. So the zeros we're finding are basically fraction or whole numbers. So, you know, all integers, negative infinity through positive infinity, you know, 1, 2, 3, 4, 5, negative 1, 2, 3, like, or some fraction. So what is not a rational number?
Pi.
True. It's another one that's not a rational number. Or it's a type of number, really.
Pi.
That's complex. That's not even a real number. So it goes beyond. That's true. We could have eyes, but there's this other thing we can have that we do see pretty common. No, that's a fraction. Anytime you can make it a fraction, it's a rational number. There's one thing that is not considered an irrational number that you see, especially in this class, you've seen it. No, zero the whole number here.
Oh, zero whole number. It's a big hole, but it's like it's
Your clue.
Okay, that's just not for me.
What's the weird looking symbol with a number under it? Yeah, radical symbol. These are not, and then some number out there. Those are not rational. So when I look at this graph, so I graphed the example, I mean, they did too on the left, example 2, because I was like, wait a minute, how can we not have a rational 0 when we're hitting X right there? Well, then they're saying, I was thinking real 0. Real numbers, these are real numbers. But we're figuring out rational zeros, which means the X value right there is some kind of a square, cube, something root. So that's why we still see a point there, but yet the problem told us no rational zeros. Because it's not rational. It's got some kind of a square or cube root or something involved. Cube, most likely, since that's. All right, so now let's look at the check problem. Wait, did we finish doing that? Oh, no, you guys were coming up with it. That's fine. All right, so let's finish that out. All right, so did you get that any of those are? None of them? What did you get?
I was doing this, and I was thinking about disaster.
Actually, I do, for you guys, I do think that's important, although now you need to do some math. No, did anybody get any of them that work? None of them work? You think -2 would work? I don't know. What's the equation?
Like
Disaster.
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 You want to know what the disaster is?
Yes.
Yeah.
Yes, it's a lot of disaster. Hurricane. Yeah. Bigger or smaller?
Smaller.
Similar?
Not weather related at all.
No, it's not. It has nothing to do with weather.
Infectious disease.
No.
Not weather. Ooh, that's the only disaster. Like fire? Like, does that count as weather related? I would. Sometimes.
A fire could be.
Oh, disaster.
No, it's not a school. It's not a school related disaster either.
Oh.
But like it's from.
Not a forest fire, not wildfire, forest fire.
There could be a fire, but
Flood weather. Flood. Not disaster. I think that's mad cow disease.
no.
That's pretty good.
You want the answer. How do you know what it is? Oh, because I told Teddy.
Aha. Give us a hint. There's nobody else in here. Raise your hand if you know the answer. Well, you know.
What are we talking
No. I mean,
I did
it's
say
possible
no.
to happen, but no, I'm saying like,
That's a hint.
yeah.
So is that a hint? No, you say no. Well, you give me your hint.
Um,
I'll tell you who has a better hint.
large crowd.
Not flash bomb.
Oh no, this is gonna be fun.
And yeah, there'd have to be a disaster. That's not a disaster. They just have to have something before that makes that happen. Aliens.
No, we tried to get Tyler Broussard tried to do that. And Miss Petrie was like, "Please God, you found." There was
Never
a
know.
pitch for zombie dogs. That one got shut down real quick.
Bombing,
No, it's not a bomb. This year.
terrorism.
It's nothing like that. I know, you want me to just tell you? It's not.
No, I had another hand. I don't give up on my son.
Program. Drunk.
The crowd is drunk or somebody else is drunk?
Somebody else is drunk.
Oh, shooting.
No.
No. Oh, I guess they wouldn't know. That wouldn't.
Rich, are you sure you don't want something? Are you enjoying it? No, he doesn't.
I'm enjoying it. Wait, which one did we say was here? Somebody thought one was. So -2 cubed is -8. -2 squared is +4, but then that's +8. -2 would be not.
Wait.
No. Yeah, the -8 and the +8 cancel out. Negative. And did anybody get one? Anybody else thinks one's work? Did you get any that work?
I didn't do all of them.
We kind of got to do all of them. That's pretty important. Nobody got one? All right, I'm not going to keep testing. That's the process, though. Oh, wait. Oh, no, they don't tell us the answer to the checkbook. So that's pretty much the whole lesson. They just get a little more complex with, like, we get more more factors, basically. Like 125 is in there. That's got way more factors. It says sometimes to test them, it's easier to like do synthetic division to think about what the factors would be. I'm not going to worry about that. Just stick with plugging it in and see if you get the answer to 0. That way we can just have one method that we know. So again, you find the possible rational zeros, and then you plug in those possible rational zeros to see if any of them give you 0. And then if they do, then that's a rational. You also do need to understand a little bit about the fact that I comes into play in something like that. We don't have a rational 0, but we would have a 0 that would have an I. Because, we did that before. X squared plus 1. Then we would subtract 1, and we take the square root of -1, and that's basically I. So I don't think give us any.
Do you give up on trying to guess?
Oh, sure. Crowd, drunk. Disaster. Maybe I'm not thinking this. I can't think a lot of like disaster. What is it? Give me a definition of a disaster.
Mass casualty event.
Okay. Yeah, so not shooting, so that. I mean, that's like driving. Is driving involved? Oh, it is involved?
Yeah.
So a drunk driver like drives through a parade or something?
That's the exact thing, yeah.
Well, that's happened before. I know. Yeah, I don't think that's a fake thing, yeah. Yeah, that's happened before.
Get it.
Yeah, that I don't remember when I can remember seeing that, but that was on the news at some point. And it happened. Drunk driver wound up taking a wrong turn or something. And you know what? Another reason why they're probably doing that. What happens this weekend? Anybody know? Gasparilla,
We didn't even plan on doing that. We just picked one and picked Melissa's. That was hers.
I don't think anything is Brady.
No, she's not in first one. She's just a Main Street.
All right. So why don't you practice? There's way more stuff that they're doing, but I'm not going to get into all of that. Oh, there, go to example. I have no idea what Descartes' rule of signs is. So if that comes into play, we'll ignore it. Do exactly what we just did. The same method, don't worry, I mean, if you want to try to follow, look at example 11. Use that, use that equation and do what we just did. So again, don't look, they did the solution for you, just use the equation. Or I'll just give it to you. 6x cubed subtract 4x squared plus 3x subtract 2. So now you've got factors of the leading coefficient and factors of the constant. So you got to deal with them. Although they didn't look like they came up with. Oh, yeah. And now the real question is, there's all my mechanical buildings. No. I did give a bunch of them away at one point, so maybe I gave them less. I did not think we did. Yeah, the class is just on my desk, not the side anymore. Not until I get in trouble for it, which.
Rachel told me that.
What's that?
Rachel said no. That's great.
Yeah,
No, that seems like.
I said no to you going to that.
I'm gonna go anyway. You gotta run me up.
Yeah, right. No, I don't think she did for the referral run. Huh. So weird. So weird. Ah. Getting sick again.
Womp womp.
Never even got over being sick.
Womp womp.
Oh. 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 I give up.
Hey, eat lunch. You have orange. Cheating?
Cheater.
Oh,
Okay, what you do on your practice? Well, that's what I do. When does softball season start? February.
yeah, February 9th, I think is our first game for preseason. And then,
Oh wait, is that the rest game?
uh,
I think somebody told me that.
there's a scrimmage game. So,
And somebody told me there's like,
scrimmage is the reps game.
yeah, the refs come out and practice, like there's been like 10 refs on the field at one time or something like that.
Yeah.
Yeah, I'd be there or
Maybe
something.
then I'll actually make some good calls. I doubt that. And then
Like, is that a game? That's just
that's just practice.
internal.
Our preseason's done today.
Oh yeah, like a preseason tournament kind of thing.
Yeah, it's like 2 days.
That'd be fun. Is that a weekend?
No, it's during the week.
Oh no.
Tuesday and Wednesday.
Yeah, we have a Bucks tournament. It's like a preseason. tournament. It's like February 6th or something. You guys not done with that one? Anybody? Looks like some people are still working on it. This is why I stopped recording so much down. We're just sitting here with nothing on. It has been recording everything you say, so hopefully you get something. And
There's sports videos of me on YouTube.
can't be that bad if they're only on YouTube.
Yeah, it's like my mom like uploaded a video that I took on her phone of me when I was like 6 years old, and I like took her phone and just like I would like make little like videos of myself, and I like didn't remember. I forgot I was recording and I was watching TV, and you can just like I have the phone like down here, and I'm just digging up my nose. It was
Come on,
disgusting.
so good to you.
I know, right?
Yeah, we used to video Jay when I was dating his mom. We video like and I have a couple of those posted like, and it's so he's 19 years old now. Actually, probably 19 now. He was 20 years old. Born in 2003, so yeah, 20 years old. And I have those to go back and show them every once in a while when I want to. Pretty cute kid. I don't know what happened.
Play-Doh?
Breathe. Yeah. That was actually from middle school. There was a lesson that I did with it, And I just, I brought all my teaching stuff in when I came here, and I never used it once. Not one time. No reason. Maybe I put them in the pencil drawer and got rid of them. I don't really use mechanical.
Are you still looking at the
Yes. Driving me crazy. Oh, I found popcorn. Yeah. Are we ready to do the check? Done? You do it? Do you? You're still working on it. Let's get started on it, and then you can always finish wrapping it up on your own. I'm just gonna skip straight to you guys telling me the factors. So, what are the factors of the constant? What goes on top? What was the constant? What's the number at the end? 2. All right, so again, it really doesn't matter if it's positive or negative because you're always going to do a positive and negative version of both. All right, so that's our positive, negative version of the two factors of the constant. And then I think 6, is that correct? So plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. All right, so there's all my potential factors, top and bottom. Make all your possible combinations. Plus 2, plus 2. I have a bunch of plus 2s. So this would be one part of your grade for this. On Monday would be your quiz, and I'll probably do something for your exit ticket from today, so that you have a today and then another day to make sure you got it down. So I just put it over every different number on the bottom. Huh? Yeah. Yeah. You mean come up with the possibles?
Yeah, like list all of them.
Yeah. I mean, that's part of the problem is what are the possibles when you can't, how would you do it without doing that? If you don't know the possibles, you can't test it, right? Well, I mean, you need to list the different ones. If you don't, if you know one's repeated, then yeah, I see. As long as you come up with all the possibles and you show me how you got them. If you skip some that are like, I'm not going to put plus 1/1, and then what would that be? Minus 1/-1. I'm not going to put both of those. So you don't have to have all those possibles. You just need to have the final all possible rational. So let's see, plus, so what I do? I did both 3's. So plus 2, minus 2. And then now 1, plus 1, minus 1. Now I basically have to do that same exact thing with 1 on the top. I don't think that creates any duplicates there. Yeah, there's no duplicates in there because I have a positive, negative version of each of those. So now I'm going to get positive 1, positive 1, positive 1. Should, I think, be pretty much the same exact thing. Although some of these will get eliminated. And then I just put on the bottom, it should really be the same numbers. I don't know why I did that. All right. So well, that's definitely all of them. Some of them will be duplicates. So I have, you mean one that you guys have? Janelle, I'm gonna start with you. So one of your possibles is a -2. So I have -2 right here. We got rid of that one. Aiden, I know you did it. Give me one. +2. That was an easy one, right? You get easy. So again, that'd be that one right there. Hannah, you get one? Give me one that you got. Or you can look at mine and figure it out. But again, you should be practicing this. This is going to be not only an exit ticket, but it'll be a quiz question next week. +1, right? That's an easy one. If we have ones involved, we know we're going to have one's a factor of pretty much everything, so that's always a possible one. So 1. Rachel, give me one. I almost wrote it down with each of those. Rachel's going to say -1. Give me one, Andrew. Third. Oh, I haven't really been marking out, so we get the ones marked out. There's actually some ones up here too, right? Because we had 2/2. So we said +1/3. Manual. I had knew that was good. I could have written that one down. -1/3. So I can go ahead and scratch those off. And actually these 2, 6 scratches off. Yeah, so far no duplicates. Christina, give me one. I'm just going to take it away from somebody and -1/2. And there's nothing else that's duplicated. So then all I'm left with is 2/3, -2/3, 1/6, -1/6. Is that what you guys got? That's a lot. 2/3, -2/3, 1/6, -1/6. All right. We got a bunch of possible rational zeros. So now, give me the. Yeah, I can do this here. What's the equation? X 6 6x cubed. All right, so here's our process. Now we just want to plug in. If we get 0, then it is a rational zero. If we don't get 0, then it's not a rational zero. But regardless, these are all the possible rational zeros. So that would be one answer. If I could do that, probably most likely that's your exit ticket right there. Much smaller equation for an exit ticket. I wouldn't make it be crazy, but you would just need to be able to come up with the possible rational zeros. Now, actual rationals, we're going to plug them in. Here's what I'll probably do to save you time, especially on one that has a lot of different possibilities. Just give me the ones that work. If none of them work, give me one to show me you know how to do it. And I'll put some instructions along that lines on it. Because that would be if I gave you one where there were some significant factors, which I probably will have one like that on the big quiz, not the exit ticket. I'm not going to make you sit there forever and go through this exercise. I mean, you still have to go through it, but if you can just that way, you can just plug in a calculator until you get one that works, and then just show the work for that one. Does anybody have the ones they think work? Give me one. Does not. All right, so -2 gives me -8. That's a really big negative number. If that's a really big negative number, then yeah, there's probably no way that cancels out. Actually, this would also be a big negative number because it's times -4. So yeah, there's no way, probably no way any -1 probably doesn't work either because that'd be -6. That'd be -4. Yeah, so these two definitely don't work. Anyway, a positive number. So I don't know that a positive is possible either. Not until we get to fractions. Fractions are going to be the one that might work because a positive number here gives me +1, +6. Subtract 4 is 2. +3. Yeah, +3 because If this is positive 2, that cancels out with that, so that's just 3. So that's not going to work. Positive 1. Positive 2, kind of the same thing. This is going to be a big number here, and I'm never going to be able to whittle it all the way down to 0. So yeah, it's looking like the only possible options are fractions. This is good practice with your calculator and the fraction buttons too. So I want you to try 1/3. If you haven't done it, you already done it. All right, try to do 1/3. So to put a fraction in, and I would do it in pieces. Don't try to put it all in at once because that causes problems sometimes. Positive 1/3, and then cube it, and then multiply that by 6. So 1 ABC 3, and I'll be honest, I don't know on these calculators if you can then raise that to the 3rd power. That might raise the 3. Did it work? You got 127? All right, so that looks like it works. And you can add fractions by doing the same thing. So positive 1/3 squared is 1/9. So subtract 4/9. Positive 1/3 there is plus 1. So if you did each section individually, that's what I got. I didn't use a calculator, but anybody else do anything at that? I can pretty much just tell you there's no way that comes out to be 0 by looking at it. I don't know what the answer is, but I know this gives me -1, and then this right here is also a negative number, so there's no way they cancel out. If I put in negative, oh wait, crap, I screwed that up. Nobody corrected me. I forgot to multiply times the 6. So now I would have to do that on a calculator. That's 0.44444. That is a little over 1/4. Still going to be a negative number, so it doesn't really matter. I still don't believe that works. If somebody got a different answer, then you can correct that. But so positive 1/3 didn't work. I don't believe, unless somebody else thinks it did. I'm just doing it in my head real quick. Let's see, negative 1/3. That's going to give me negative 6/27. That's actually going to be an even bigger negative number. They're all negative if I use negative 1/3. So I don't think any negative number could possibly work because I'm going to get a negative everywhere. So yeah, there's no way. So negatives can't work. Does anybody understand what I'm saying? Like if I use a negative number, this becomes negative because that part becomes negative. Cubing it makes that a negative. This is positive, but there's times a negative. This is positive times that'll be negative. So this will be negative. So every term is negative. So no negative number is going to work. I can cancel again, you get a different result, let me know because I'm just thinking it through in my head. All right, we just did 1/3. 1/3 didn't work. All right, so 1/2. 1/2 squared. I'm sorry, cubed. 1/8, so that's 6/8. 1/2 squared is 1/4 times -4, though. Will be subtract 1. 1, yeah, that's not going to work. Because 1/2 times that is plus 3/2. And then there's, oh wait, hold on, maybe, no, this is not in halves. Okay, that's not going to work. Yeah, that's not going to work. Again, if you're getting a different result, let me know. How about 2/3? That didn't work either. All right, so 2/3 would be what? 8/27. 8 times that is 48/27. So if I square it, I get 4/9. Subtract 16/9. That's going to cancel out, so I just get +2, subtract 2. Those go away. Oh, they want to try that one in your calculator. Try that one in your calculator. Try 2/3. And then, unless I'm mistaken, that gives me 0. Do it in your calculator. Tino, do this in your calculator. Yeah, see, that's why I want you to try it, because this one's not even easy just to do in your calculator with the numbers. Especially since remember, well, it's not a negative that value, but don't forget when you put in negative whatever and then you use the squared button, it gives you a negative number. People are still making that mistake. I just square each number separately. I just say, I'm sorry, cube. I just say 2 cubed to get the numerator and then 3 cubed to get the denominator. Let's see. I do want to know how to do it. Works. Yeah, you got to know how to use. Of course, these are probably not the calculators you get on the SAT or ACT. Probably the one. Probably should be those schools. There's a button. It raises any number that only. It's a little up there. Oh yeah, right there. I was looking at the second function button. But yeah, it's main function. Now you need to put it in parentheses possibly. I'm going to do it without parentheses first. And then raise that to the 3rd power, but I'll bet it gives me 2 9s. Oh no, it didn't. Yeah, it worked. 8/27. So yeah, so that works. So that raises 2/3 to the 3rd power. What did somebody just say a second ago? Did you get that this works? Yeah, good work. Because if you do each piece separately, which is what I would encourage you to do, those are the pieces you get. And if you on your calculator and the +2 subtract 2 cancels out, so I got rid of that. So now we would say, all right, well, 48 ABC 27 subtract 16 ABC 9 equals 0. Means it worked. Did anybody do 1/6? Yeah, let's try 1/6 because we've done all the other ones. I didn't really do 1/2, but I'm pretty sure. Well, yeah, we did. Yeah, we did. We had 6/8. Subtract 1, so that would be -2/8. -2/8 plus 3/2. Yeah, that right there is going to ruin. Oh, wait. Hold on. Yeah. That would be times 4 times. Oh, I might have been wrong. This times 4, that times 4. No, I won. I didn't win. I still don't think the 1/2 worked. We should have mentioned. Yeah, so it says in the book, the only one that worked was 2/3. So that was the only, so 1/6 won't work when you try it. All right, so that's the process. Exit ticket will be a pretty simple problem where you just come up probably with just a possible rational zeros. That's just the first step. I'll make it less factors, probably a few factors.